And we're going to run out of gas. And this is fantastic, and I'll tell you why. Because now we won't leave space junk. This is going to go back, fall back into Kerbal, burn up into the atmosphere, and we will not leave that trash orbiting. It's called space junk. Okay, so here we are. We're actually in a positive periaptic state right now. And we're growing to 22. We're going to try to get to 29. I can actually start to go really slow. And I don't have to really do anything till I hit 0 here. At the apoapsis peak. Let's go look at that on the map. See? This is growing. It's at 34. We're 11 seconds from that at 79. So that, and we're not gonna. I said we could use half our fuel to get there. We're only doing a flyby, so we don't need any fuel. We can do what we call a return trajectory orbit, like the Apollo program. So no matter what, it brings us back. If we die, we'll come right back. It's not a pleasant thought, but if it's all set up and it just brings you back no matter what, if you have major failure, you're just coming back. You got all that time to figure it out. So here we go. We've just passed our point of apoapsis, which if we give it a little gas, you can see it comes towards us anyway, because we're really powerful right now. Close to the 70. Alright, now when I hit 70 right there, we just made space. So I'm going to try to match this by putting a point here and a point here. Watch what happens. Up, went a little hard, but basically what we have is a very close to concentric orbit. Alright, so we're 2 minutes into the video and we just achieved near Kerbal orbit, and our next step is just to go right onto the moon. What we do is we set that as a target. You can check your ascending and descending node. If we have time, I'll adjust those to perfect. Well, let's show you how you do that. So, have to know how to use the time warp, so I just set on the line and went warp here. Okay, this is the ascending node. So what we do is we put it on the one with the targeting vectors right in the middle, and then I'll light this up to show you what happens. And here, let's look at us out here. Oh, you can't see us, but basically we're pointed straight north, straight up and down. And this is going to change our plate, that the angle our plate tilts. And it's all about the grain of the universe. If you ever look up at the moon, and you can sometimes see Mars and Venus, they look like stars near the moon, but they're actually planets you can see with the naked eye. And the reason you find them by the moon is because they're all on the same platitude, planular angle, latitude. And what that basically means is if you see the yellow line and the blue line, I now have aligned those perfectly. If I back up, you can see they're on the same plane. Anyway, so I just adjusted that. I have an ascending and a descending node of 00. Alright, hallelujah. So the next thing I'm going to do is go for the moon, and I need to come to warp to about here to get there, and place our azimuth, or the direction our nose is pointing. There's also the direction we're traveling, which can be two different things, but we like it when they're the same. It makes everything simpler. And let's go back to the map. What we have is the moon. I'm going to change the view a little bit so we don't feel so much like we're flying, and we feel more like we're circling a planet on the proper plane. Alright, so what I'm waiting for here is the moon to come onto the horizon. the moonrise. And I can see it right here. This is my trajectory of the moonrise, and what this means, see how it's behind the brown? It means it's over here on the Earth. But it's coming this way. It is. We're going to see the moonrise. Anyway, while we're waiting for that, I'm going to go ahead and check my Kerbal out. So see how he's in nice visual readiness for this. Alright. If we were impatient to wait. Oh yeah, see his mesmerization? He's having a good time. He's like, wow. Alright, so here it comes. I'm just going to speed it up just one little notch just because I'm impatient. Here it comes. I can see it on the radar blip, but not in reality. Okay, there it is. So when this happens, what you do is you want to give it all the gas you got. Now don't run out of gas. But it came on the horizon. Now what this does is it's allowing us to plot a course over here in this direction, and we're going to meet the moon because it's moving from here to here, and we're going to move from here to here, and we have two curved lines that have to collide, and I really have to be careful to watch my gas right here. This is the part of the mission that we're running by the seat of our pants, and we're not really planning, so I'm getting really nervous. I need to open this window. Yeah, I'm almost desperate. I did say almost. Alright, so see this periapsis here at 1920? We're going to put that on 37. Actually, I'm going to bring it back to 30. And this is our return trajectory orbit. Alright, we're going to leave it right there. No, we're not. We're going to do this. I'm going to come in here and we're going to limit our thrust value to 10% because I'm having trouble controlling the finite. And I need to put it back on positive. I need to put that about 29 or 30. Alright, I can control it now that I've backed off that thrust. 30062. Okay, what this is it's a return trajectory orbit that's going to collapse this giant elliptical orbit, and this will come back to Kerbal in a couple rotations, maybe one or two rotations, maybe none, and we will plummet back to the planet's surface with no choice of our own. Why do we want to do this? Because we're terribly low on fuel, almost none. So anyway, that's primarily the beginning and the end of the mission. We either did it right at this point or we didn't. So what we want to do is we want to start accelerating ourselves for the sake of time, because this is a 4-day event, like 12 hours. And we don't have time to do that in a 20-minute video. Plus kids don't have time to do that if they're learning. So basically what I want to do is come about here, halfway. And this is high space. We're between the planets. We're technically still in a Kerbal orbit, but if we actually go look at our instrumentation, let's go ahead and open this up. We will log temperature. Look, 12 points. Pressure. Mystery goo. Crew report. Now we have to transmit this one back. So you saw our antenna drop down. Maybe you did, maybe you didn't. And that's our long-range antenna that allowed us to get that done really quick. It used a small measure of electrical charge, which if we just kind of tilt the craft like that, then we can start to recharge our batteries. If you see, they're already coming back. And then the only science there's left to do is the EVA. So we get out of the capsule, and it's basically an observational report. It's a spacewalk. That's our first spacewalk. Deep space. Okay, now I'm going to go back out, and I'm going to collect the data. Little warning, if we remove that, it destroys the experiment. You won't be able to use it again. Yeah, we knew. Right. Board back up. The reason I had to transmit my crew report is because I can only hold one crew report at a time in the outbox, I guess. And I want to take another one in near space orbit, so I'm going to just come right up to my periapsis at here. You can see as we get close to this transition point, it's pulling our speed way back. By the time it actually grabs us, we'll be traveling as slow as we fly on the planet. Like, that's hardly any speed at all. So now we're in the hold of the moon's gravity, but it can't hold us for too long. It's going to release us right here and put us back into this orbit at about right here, where this area gets light and dark. So let's collect our science. And this time we're going to get the material bay. Look at that, 50 science points. That is fantastic. Mystery goo. Which mystery goo is a gravitational thing. They're kind of joking about actual NASA experiments. Now, the thermometer, there's nothing wrong with that, taking temperatures. That's exactly, literally, a NASA experiment. But the mystery goo, I mean, of course they called it something else, but it's basically you open a vacuum tube, you get a goo in a vacuum tube, and the vacuum holds it in place, and then you go somewhere and you open it. And what does this do to the goo? It either collapses it to the bottom, or it kind of just sits there and goes, and kind of moves around. But anyway, it's just an observational experiment. It's actually pretty silly. Crew report. We're actually going to keep this one this time, because we can. And then we'll do an EVA and collect. Wrong side. I knew it was the wrong side because I checked the thermometer and I couldn't get to it. Take the data. Board the ship. Alright, and then we're going to close this. I'm going to close these doors just because I think it looks better. We cannot reset that experiment, and I may choose to if I am in radio range, and I'm not really, so I'm going to demonstrate the antenna. Review my crew report. Now watch this antenna when I put transmit. Drops down, transmit, you can see it over here, and it'll close back up. Alright, so the next thing we need to do is come back to Kerbal. So let's watch this. We're going to be watching our speed go up. Alright, then we'll watch ourselves as this turns blue. We're back in the confluence of the Kerbal orbit, or the influence of the gravity. Alright, so then let's just kind of, we have all our experiments, let's just warp here. So what you are going to see is this speed go up as we pull away from the apoapsis and dive towards the gravity, and that's because there's almost no gravity hold up here. Remember? And remember an M, talking like an Australian in a movie. I'm thinking of Mad Max right there. They told him the story. It was really cool. The kids with like heavy slang. Alright, so as you can see, we're almost up to 3,000 meters per second. Okay, that's like 7 times faster than a bullet. And then as we get to the 70,000 mark. Alright, so I have these missions here. Let me... No, these are surface readings. If I was flying over one of these aboves, that's the only one I could do, is take a temperature reading if I was coming over the top of that. Alright, so you can see us closing in on 94. Now we've just hit 69. We kind of need to be in the safety position, which is like this. Alright, everything's going to start catching on fire and blowing up because we're moving so fast and we're coming into the altitude so quick. And then look, this is going to start to pull down a lot. So we'll just come back and check that later. What we need to monitor now is things blowing up and breaking. We do have a little bit of gas here, but I really wouldn't want to hit that until we hit the bottom of our periapsis or an overheating state, like we're overheating right now. See? So if I shoot my gas about before I blow up, see it's climbing, it's actually going to start to pull my speed down. And before I run out of gas, it's pulling this down at a faster rate. But it is going to blow up, I can see it. So we need to stage before we blow. We're going to wait till the last minute. Alright, it's coming back. It's not going to blow. Alright, see, we had a very, very, very small orbit. I'm not comfortable anymore. I'm going to stage. Alright, so I just let that gas tank go. And now I'm a ship flying towards the planet. The periapsis is in front of me, and this has just dropped below 70. So we are coming back to the planet, no matter how we feel about it. Our solar panels may explode. We're just going way too fast. Now, what we're hitting is the heavy air right here, so it's air braking us. And our parachutes are on auto, so they're going to open at the appropriate altitude, whether we push the button or not. So basically, it's just along for the ride at this point. We set it up, and now we're going to live with the results. It's an interesting way to fly. Align the parameters and hang on tight. Alright, so we'll just wait for our two places we're going to go. And one's about 260 meters per second. That's when our chutes will open. Another place to go is about 3,000 meters above sea level. That's the other place our chute opens, and we need both these conditions. So at 15,000, I'm got a ways to go, and at 400 or 500, I have a ways to go. Here's the big waiting game. Are you too heavy? Is the question. Usually the answer is no. You have to be pretty big or full of liquid. Size means nothing. It's about mass anyway. Well, size does, because size can actually have a greater surface area by which to act as a better parachute in the atmosphere. So the bigger you are, the better off you are in some cases, but that's offset by how heavy you are. I see our first set of chutes open, and we're about 3,000 and the 200 mark. Oh, we have the other one now. We're waiting for them to blossom and land. So anyway, that's the next mission, which is a flyby of the moon. This was technically our second mission. I'm not counting that little science collection bug thing we did to add one more component. We did take the component that we bought with us, although I don't know how much it really contributed to the mission. But as far as the tech tree goes, it all has to be achieved in a certain order. And there's some parts I almost will never use. Have always had the option, but just I guess I prefer other things. It's nice to have variety. And you can make all kinds of crazy landers. And we're at the point now where in the beginning the ships all kind of look the same. We're at the point now with just a small amount of creativity. You can create a pretty diverse range of visual ships, but you know, physics are always going to be physics, and thrust is always going to be thrust, and aerodynamics are always going to be aerodynamics. So I guess it's like the Pinewood Derby on Boy Scouts. You can make those cars look so many different ways, but then when you get right down to the formula, there is a perfect Pinewood Derby car. And those all look the same. Pretty cool how they scientifically figured it out. You have to know about the track, you have to know about the wheels, you have to know something about aerodynamics, where to place your weight. Is it better pushing you or pulling you down the track? Ooh. I mean, we bought our little Pinewood Derby kit, and I think my dad wanted to work on it. He, I don't even know what we did with ours. I think Dad just took over. I remember though, he cut a shape this way, and then he turned it, and he cut a shape this way, and he must have known what he was doing, because he somehow took a block of wood and made it look like a real car. And I even think he had a certain model in his mind somehow. And it's basically cut this way, cut that way, and then sand the sharp corners round. It turned out really looking nice, and it was pretty competitive, but we didn't stand a chance because someone had the formula to build the perfect car. That was back in 1970. I want to say 1973 or 74, one of those. Alright, so we actually could take a crew report there. I remember being in the water before when we couldn't take a crew report. And I think we've got everything else except possibly, oh, we don't have an available mystery goo. Let's just go ahead and recover. You'll be surprised how much science we actually received from just a flyby of the moon, and when we go into orbit, it's pretty much the same thing. Now remember, we got high space over Kerbal and high space over the moon in one shot, 147. We've got money. Alright, so we're going to go ahead and do this. Now we can collect surface samples. One thing I'm really hurting is not having this, but I'm able to do things without patched conics. Like, maybe it'll let us project. No, I don't. I don't want to say too much too quick. I'm starting to think about the future, excuse me. So, let's just go look at the next mission, which now they want us to go and stay in a stable orbit and perform a spacewalk. And don't just leave it there, they want you to bring it home back. Which, just achieve orbit and come home. That's easy. We're taking that. No, I don't think I want any of those things. I hate to get stuck and then have to pay the penalty later for giving it back. Alright, so it looks like we're closing in on the 58-minute mark pretty quick, so we have to be done. So let's just go in and look how much science we have. We can have 2 items off of this list. And if I wanted 2 items, I would take heavy rocketry right there, and then they have some tanks that go with it. These two kind of go together. If I was going to come down here and buy some of these things go together. I wouldn't want one without the other. So that's why I did that. This is the only part I'm lacking or would be liking that I won't have. And also this Clampeton docking port. So I could go collect science from around Kerbal, and I may need to do that. But at this point, I'm not going to make the decision, and I just wanted to tell everyone thank you for watching, and I hope you join me again next time for our orbit and our spacewalk. And then the very next mission should be walking on the moon. So anyway, we've run 1 mission, 2 missions, little science grab in between, and we're here where we are ready for the 3rd mission, 4th mission, walking on the moon. Anyway, this is the percolated, accelerated path for the person who already has the basic core experience and does not want to go through the grind again. Once their part's a little quicker, once their experience is faster, really doesn't need to learn the core anymore. Has real strong core values. But anyway, as always, Kerbal Space Program 1.8.1. This is Paced X Pilot and Space Training Experience. Thank you for watching. Have a great day.